Picture this. You board a spaceship, the most advanced machine humanity has ever built. Engines firing, systems online, you point it toward the other side of our galaxy, and you go. Full speed, non-stop, no delays, no detours. And you travel, and travel, and travel. And by the time you arrive, every single person you have ever known, every civilization that has ever existed, every building, every monument, every memory of humanity itself is gone. Not metaphorically, actually gone. We'll come back to exactly what that means and the number behind it at the very end of this video, because when you hear it in full with everything we're about to cover first, it will hit completely differently. But before we get there, hey, quick question. Where in the world are you watching this right now? Drop your city or country in the comments. I'm genuinely curious how far this reaches. Now, let's start from the beginning, because to understand how disturbing that answer really is, we first need to understand what we're actually dealing with. Look up on a clear night, away from any city, away from any light. No phone, no street lamps, just you and the sky. If conditions are perfect, you'll see it. A faint, hazy band of light stretched across the entire sky like someone smeared chalk across black velvet. That's the Milky Way, our galaxy, the structure we live inside of. And here's the first thing that should already unsettle you. That glowing band, that breathtaking, almost spiritual sight that has made humans stop and stare for tens of thousands of years, contains roughly 2,500 to 3,000 individual stars visible to your naked eye. Sounds like a lot. It's not even close. Our galaxy contains somewhere between 100 and 400 billion stars, possibly even more. What you see with your bare eyes on the clearest night of your life is less than 0.00001% of what's actually there. The rest, too far, too dim, simply invisible to you without help. Now let's talk about size, because this is where it starts to get genuinely hard to process. The Milky Way has an estimated diameter of 100,000 to 200,000 light years. One light year, just one, is roughly 9.5 trillion kilometers. The distance light itself travels in an entire year, moving at 300,000 kilometers per second. And our galaxy isn't 1 light year wide, or 10, or 1,000, up to 200,000. Here's a comparison that might actually break your brain a little. Imagine shrinking the Milky Way down to the size of the entire continent of Africa. At that scale, our solar system, the sun, every planet we've ever discovered, every probe we've ever launched, everything we have ever touched or seen or imagined in space would be roughly the size of a single grain of sand. Not visible from across the room, not noticeable on a table. A grain of sand sitting somewhere on an entire continent. That is us. That is our place in this one galaxy. And here's the part that most people skip over entirely. The Milky Way is not the universe. It's not even a significant part of it. There are an estimated 2 trillion galaxies in the observable universe. 2 trillion, each containing hundreds of billions of stars. Our galaxy, the one we cannot even begin to cross, is one barely noticeable point among 2 trillion others. This is the stage. Now, let's talk about the journey. So, you want to cross it. You want to go from one edge of the Milky Way to the other. What do you take? Let's start with what we've actually built. Right now, today, the fastest human-made object ever launched is the Parker Solar Probe. It was designed to study the sun from an extremely close distance, using the sun's own gravity as a slingshot. At peak speed, it reaches approximately 700,000 kilometers per hour. 700,000. That sounds enormous. At that speed, you could circle the entire Earth in under 4 minutes. So, Parker Solar Probe, full speed, non-stop, one edge of the Milky Way to the other. How long? Roughly 1.5 billion years. Let that sit for a second. 1.5 billion years ago on Earth, the most complex life forms that existed were simple multicellular organisms. There were no fish, no insects, no plants on land, no dinosaurs. Those came much later. No humans, no civilization, nothing we would recognize as life. And if you left today at the fastest speed we have ever achieved, you would arrive on the other side of our galaxy in a future so distant that the sun itself will be in the final stages of its life. But okay, maybe that's not fair. Parker wasn't designed for deep space cruising. What if we imagine something much faster? What if we could somehow reach 1% of the speed of light? That's roughly 10 million kilometers per hour, about 14 times faster than Parker at full throttle. Cross time at 1% light speed? Still 20 million years. 20 million years. What if we pushed it further? 10% the speed of light. 2 million years. Still longer than the entire history of the human species, multiplied by a factor of almost 1,000. You see what's happening here? We keep increasing the speed dramatically, and the number barely seems to move in any meaningful human sense. Because the galaxy isn't just big, it's big on a scale that makes even extreme speed feel pointless. And this is the moment in the video where most people start to feel it. That quiet, low-level dread, that sense that the universe doesn't care about our engineering, that the rules don't bend for ambition. But here's where it gets philosophically strange. Physics has a speed limit, the speed of light, approximately 1.08 billion kilometers per hour. Nothing with mass can reach it, not because we haven't figured out the engineering yet, because the universe itself forbids it. As you accelerate toward light speed, the energy required doesn't just grow, it approaches infinity. The universe isn't saying not yet, it's saying never. But, and this is a remarkable but, it doesn't say you can't get close. This is where the story gets strange, beautiful maybe, but also deeply unsettling in a way that no number has been yet. Imagine a spaceship traveling at 99.9999% the speed of light. Not light speed, close to it. Close enough that something extraordinary happens. Something Einstein described over a century ago, and something the universe actually does permit. Time itself slows down on board. This is called time dilation. It's not science fiction, it's been measured. GPS satellites experience it. Atomic clocks on aircraft experience it. It is real, and at extreme speeds, it becomes extreme. At 99.9999% light speed, the Lorentz factor, the measure of how differently time flows on board versus outside, reaches approximately 700. That means for every single year experienced by the crew of that spaceship, 700 years pass for everyone watching from Earth. Now apply that to our journey. From Earth's perspective, crossing the Milky Way at near light speed takes around 200,000 years. But for the crew on board, due to time dilation, that 200,000-year journey compresses down to roughly 285 years experienced on the ship. And there's a second effect layered on top, length contraction. At those speeds, space itself appears to compress in the direction of motion. The galaxy, 200,000 light-years wide to us, would appear, from the traveler's perspective, to have physically shrunk, like the universe folded itself just for them. So the crew could, in theory, cross the Milky Way within a few human lifetimes. And here is the moment I promised you at the beginning. Here is the disturbing part. While those travelers aged 285 years on board their ship, while their children were born and grew old and died inside that vessel, back on Earth, 200,000 years would have passed. Every person they ever loved, gone. Every country, every language, every trace of current civilization, gone. The pyramids, eroded into dust. Every book, every recording, every monument humans ever built, vanished. If they sent a message home the moment they arrived, traveling at the speed of light, that message would take another 200,000 years to reach whatever, if anything, still exists where Earth once was. They would be the most isolated beings in the history of conscious thought, not separated by distance, separated by time, unreachable, unrescuable, completely and permanently alone, not in space, but in history. And that's assuming the ship survives. At 99.9999% light speed, a single microscopic dust particle in interstellar space would hit with the energy of a nuclear detonation. The engineering challenge isn't propulsion, it's building something that can survive contact with almost nothing at nearly infinite relative energy. So here is the answer, the actual full answer. To cross our galaxy with current technology, over 1 billion years. To cross it at near light speed as an outside observer, 200,000 years. To experience crossing it at near light speed on board, 285 years. But you return to a world so far in the future that humanity, in any form you'd recognize, almost certainly no longer exists. There is no version of this that ends with you coming home. The galaxy isn't just large. It's large enough that the laws of physics themselves cannot save you from what that size means. And maybe that's the most honest thing the universe has ever told us. We are here. We are small. We are brief. And the stars, even our stars in our galaxy, are so far away that we may never touch them. Not because we aren't clever enough, because distance at this scale is time. And time is the one thing none of us, no civilization, no species, no planet gets enough of. If this made you feel something, share it with someone. And if you're still wondering what's beyond the Milky Way, the next video might make this one feel small. See you there.